Alright, so here we are and we have this face. And faces inherently have lines, which means that we have and points, so we have some vectors here. Now, I wanted to introduce one more formula that you can use with vectors that can be helpful in a few different situations. Let's say we had this face and the normal was messed up, and we wanted to figure out what the vector was facing out from this face. The way that we would do that is we would figure out what the vector is here on this line and the vector on this line. And then we would get the cross product of those two vectors, and that would give us a vector facing out, or orthogonal from both of these vectors. So how do we do that? And let's open the script editor to start working that out. So first we would import OpenMaya, so we have our mVector class to work with, and then import the Maya command, so we can use the xform command and various other things. And now I'm going to get the position of the vertex at A, B, and C. I'm actually getting the vertices off the plane, getting the world positions of the vertices on the plane. So A, B, and C. So now that we have these points, we get the vector, the m vector of A, B, and C. So these are all things that we've already done. And then just like before, just to show what we have now. So we have this vector, this vector, and this vector. So vectors A, B, and C. Now to get B, the vector from B to A and B to C, we need to subtract B from A and B from C. So now we go, say D, E. So D is C minus B, and then E is A minus B. And what that will give us is this position here and this position here. So just create some locators at those spots and draw splines between those. So now we have these vectors visualized. So this would be E, and this would be D. So these vectors here are exactly the same as the vectors on this plane. We've just drawn them down here. So now how do we get the cross product between these two vectors? So this is basically what the math looks like. This is not typically how I would do it, because there are functions already built into mVector class, and it's also faster to do it using the built-in classes, like when you're running your script if you had to do this a bunch of times. But just so you can know what the math is for getting the cross product, I'll show you. So if we were to take d dot y times e dot z minus d dot z times e dot y. So you take the first vector is y, multiply it times the second vector is z, and then minus that times the first vector is z times the second vector is y. And then go d dot z times e dot y minus d dot y times e dot z. D dot x times e dot x, no, y z x, z y, x. I did this wrong. It's actually z, x, y. This would be x, and that would be z, minus dy times e dot x. So this is a formula, so if you don't have it memorized, it's very easy to get it wrong. So the only reason I remember what it is I know that I start with y on the first vector when I multiply, and then I start with z on the second vector, and then I know that I always go 1 over. So if you look at the two vectors, x, y, z, x, y, z, the first vector starts at y, and then you go 1 down, then it goes to z, and then you go 1 over, and then it goes to x. So it's just walking from left to right, but it starts at y. And then on the second vector, it starts at z, and then it goes x, then y. And then once you have this first part, the other side is just flipped. So it goes, when it goes d dot y, e dot z, then it goes d dot z, which is the same as this side, and then it goes e dot y, which is the same as the other side. So then we get these three portions of the cross product. And that gives us a locator, should be way out there. And then that's our vector. Now this vector is really far out, just like if we were to do dot product. It's very useful to do a normalize on the vector. So I will normalize it afterwards. But before I do that, I'm going to show you the easy way to get the cross product without having to use this formula. I just wanted to show you the formula so you knew what was going on. So say f equals d, and then you go caret e, and the caret tells the m vector class that you want to get the cross product between these two vectors. I can also say normal, normal, then e dot normal. So now I got the unit vectors of those two. And I'll create another locator to represent where that is. So f x, f dot y, and f dot, z. And that gives us this unit length vector right here, which is the cross product of these two vectors. And I can add it back on to B very easily. Say G equals B plus F. Replace F with G. Now we get this point up here. So if I remove those vectors, I can just draw a quick move these. Then you can see that this line here is perfectly orthogonal to the other two vectors, and you have your cross product.